Hey guys, welcome to Coronavirus Earth Science Weather Day 10. Today we're going to talk a little bit about clouds. Okay, reminder, these are your grades that you'll be getting at the end of the week. This is homework and this is a lab. Make sure that you get them done. All right, I'll be checking them on Saturday. All right, here we go. So how do clouds form in the troposphere? All right, you should remember troposphere from when we did layers of the atmosphere. That's the first layer, and that's the only one that really experiences weather because it's the only one that has really any water vapor. All right, there might be a little bit in the stratosphere, but it's mostly all taking place in the troposphere. All right, so here we go. How do we define a cloud? A cloud is a collection of millions of tiny water droplets. All right, and what makes it look like a cloud is that you got those droplets and even some ice crystals, right? And they're suspended, they're kind of hanging out in the atmosphere, but they are all kind of clinging to these dust particles, okay? So those dust particles are what all those droplets are basically collecting on, all right, what they're binding to, and that's what makes your cluster of clouds. All right, and you should remember condensation is when you have gas turning to liquid. All right, and remember, I just wanted to bring this to your attention again. This is your Earth Science reference tables, page 1, and right now we are talking about this, right? Heat energy released, because it's a cooling process during condensation. All right, so when condensation, in order for it to occur to 1 gram of water, it must release this much energy per gram. Okay, so it's basically getting colder by that many joules in order to convert from gas to liquid. Okay, so the making of a cloud. Let's check it out.
Most of the time, if we pay attention to clouds at all, it's because of their effect on our local weather. Or maybe it's because they make the sunset prettier. But what you might not know is that clouds affect us every day, even if we're staring at a clear blue sky. The clouds we see when we look out the window are important components of a complex global weather system. They play a key role in Earth's water cycle, carrying huge amounts of fresh water and dropping it as precipitation. And depending on their properties and where and when they form, clouds can have dramatic effects on our climate, influencing the locations and severity of floods and droughts, and even the temperature of our planet as a whole. So by understanding clouds, we can better predict severe storms, the global distribution of fresh water, and the course of climate change. But what exactly are clouds, and how do they form? All clouds share the same basic ingredient, water. They're made up of water droplets or ice crystals that have formed from water vapor in the atmosphere. Although you can't see it or feel it, the air around us contains water, even on the clearest summer day. The main sources of this vapor are evaporation, which is the escape of water molecules from the surface of oceans, lakes, and soil, and transpiration, the release of water by plants. As the sun warms Earth's surface, heat is transferred into the atmosphere along with water vapor. The warmer the air, the more moisture it can hold. But warm air doesn't usually stay near the surface for long. Like a hot air balloon, it rises. As it does, it cools. The colder the air becomes, the less water vapor it's able to hold. If the air becomes cold enough, it reaches a state called supersaturation, which causes some of the water vapor to transition back to a liquid or solid state. Water molecules in the vapor form around tiny particles of dust, ice, sea salt, and pollution suspended in the atmosphere. These particles, called condensation nuclei, serve as the starting point for the formation of water droplets and ice crystals. With this final step repeated billions and billions of times, the water that's been in the atmosphere all along is suddenly visible, and a cloud is born. While we can now see the cloud, the individual droplets or ice crystals are tiny, which is why they remain airborne. But they can combine to form larger drops or crystals, and if they become large enough and too heavy to stay aloft, they'll fall as rain, snow, sleet, or hail back to Earth's surface, where the water in them came from originally.
All right, so that explained it a whole lot better than I could have. But essentially, all you have is you have your warm water rising, and it's rising because it's expanding and becoming less dense. And then as it's up in the atmosphere, it's going to cool. And when it cools to the dew point temperature, right, that's when you have your condensation happen, all right, which is when you get your gas to liquid. And that's going to form around those condensation nuclei, which are the little dust particles, little pollution particles, ice crystals, and you get your droplets accumulating, you form your cloud, and then eventually, when they get too heavy, that's when you get your rain, okay? And rain is good because, as you see here, it cleans the atmosphere by taking the dust and other particles out of the air and bringing it down to Earth. All right, so that is essentially your cloud action. So warm, moist air is rising. Up top here, it's cold, so your condensation's gonna form and form your cloud. And that's it. How would you describe the different types of clouds? You guys have heard of like cumulonimbus and cirrocumulus and stuff like that. There's many different types. Cirrus are the high wispy clouds that you see during your nice weather. So that's mainly going to be your high pressure. Stratus, middle horizontally layered cloud. It's nothing too crazy, still pretty nice. Cumulus, the low fluffy clouds with flat bottoms. Nimbus are the rain. So anything that has the nimbus or the stratus or nimbo, or if it ends in nimbus or it starts in nimbo, that's going to mean rain. And that's really the one that I want you to really remember. Yeah. Okay, so little summary action. The incomplete flow chart below shows some of the changes that occur in warm air as it rises to form a cloud. Which statement would be placed in the empty box to accurately complete the flow chart? So warm air is going to rise. The air expands due to the lower pressure. And then as it's up there, it's going to cool to its dew point, right? This is where it cools and it's going to start changing from gas to liquid. And that's your condensation, right? Number 2, in order for clouds to form, cooling air must be saturated, right? It gets filled up with all that water vapor, and then it's going to have those little dust particles, the condensation nuclei for the droplets to form around. All right, number 3, in which air sample will condensation most likely occur? Which one is going to have the air temperature be the closest to the dew point, and it must have those condensation nuclei, and that would be 1. All right, so even though choice 2 had them they had them the same, they didn't have the nuclei there to form. All right, so that's that. No worksheet for that today, so use it to catch up on other work. Adios, have a good day.